Thanks for having me. Hello all. I want to tell you quickly about how we can abuse the fact that coroutines are transformed by the compiler to a state machine. So we have here for events types like open, close, and knock. We have states closed and open. And finally, we have the implementation of the state machine, the door, and we have a state, which is defaulted to closed, and a method in which we pass our events on event. And here we have a state machine, but it's not yet implements using coroutines. It's just like using switch. We have here we have to switch on the current state. If the current state is closed, we see what type of event we got. If it is knock, we just answer with some line. If it is event open, we open the door and go to the state open. If it is if we are in the state open, we only expect an event closed, and then we immediately go to the state closed. Okay, here we can use our state machine, something like that, and we send events, we go between states, and we can get output like that. Okay, now knowing that compiler transforms our coroutine, our written coroutine, into a state machine, we can use that fact and have a coroutine which will handle events. And we can write it like this. We go wait for an event, or for an open event or a knock event, and our coroutine suspends until we have that event passed to us. If we got an event of type knock, we just answer with a line. Otherwise, we transition to state open, which we can see here implicitly. And in that state, we just wait for event close. And after we get it, we come back to the infinite loop and start all over again in the implicit state closed. Okay, we can rewrite that using labels and goto, and for some reason I like this better than the previous example. Blame me. And what we have to do to implement such features for our state machine. We have a type for listing events we are expecting. We have some magic, we will get to that a bit later, and we have some stuff that's related to lifetime management and whatnot. Okay, let's get to the magic. We have our promise type, and in that promise type we have type erased current event, and we have a pointer to function is wanted event, so that we can specify which event do we expect, do we want to handle. And we have an ordinary from other methods of this class, await transform, which allows the promise type to inspect what type we are awaiting on, and transform it and return some different type for coroutine to await on. So here's our await transform implementation. We, for a particular set of events, a set of types, we specify that we expect exactly that types using fold expression. And next piece of implementation is awaitable type. And here the unordinary part is await resume. That is when our coroutine is resumed, when we got the event that we want. We go through events that we are waiting and try to cast our type raised any event stored in any to the event we want, and place it into a variant. Next, we have our method onEvent, which handles events, and here we check if the particular event that was passed is wanted, that the event that we are waiting for, and that store it into the type raised storage, any, and resume coroutine. And we get a very similar usage example, and we get similar output. Now we can very easily customize our state machine by providing arguments. And here we can use it like that. We just provide different line and the code otherwise unchanged, and we get slightly different outputs. And that's all that I have. Thanks.